All right, guys, in this video, we're going to do questions 19 and 20. Number 19 says, solve the problem. There are 12 members on a board of directors. They must elect a chairperson, a secretary, and a treasurer. How many different slates of candidates are possible? Okay, we can do this in two different ways. Number one, we can use the fundamental counting principle. And using the fundamental counting principle, they must select a chairperson, a secretary, and a treasurer. So let's label each. Now, if you notice, there's an order to these categories. Chairperson being the first, then a secretary, then a treasurer. So the order matters. Let's put that up here. Order matters. And also, once you're chosen, you cannot be repeating. So there's no repetition. And these are distinct roles. Distinct / different roles. Once you're chosen, you can't be chosen again. That's it. So, for example, if there's 12 people possible to become chair, once a chair is selected, that person is out of the pool, which means you have 11 left. And then from there, you pick your secretary. After that, you have 10 left. So if you notice here, for our problem, this is also a permutation. So let's use the fundamental counting principle first to answer this question. This is going to be, you have 12 candidates that can possibly be a chairperson. You choose one. There is 11 candidates left to be the secretary. One is chosen again, somebody totally different. Now, 2 people cannot be repeated, which means we have 10 people that can possibly take the place of treasurer. And because it says how many ways, or rather, how many possible slates of candidates are possible, if they must select a chairperson, a secretary, and a treasurer, we can multiply. 12 times 11 times 10 equals to 1,320 ways. Okay. Let's actually solve this by using a permutation. The order matters, there's no repetition, and there are distinct and different roles. We have a total of 12 candidates. So N is how many you have, 12 candidates. R is how many you're choosing, and we need 3 roles, so we're choosing 3 candidates. And once again, the order is important. So that is the permutation. Let me block it off right here. That's going to be the permutation of 12 candidates, choosing 3, and the order matters. And we're using the permutation formula. Matter of fact, where can I write the permutation formula? I'm going to write the permutation formula up here. That is n factorial divided by n minus r, the entire quantity, factorial. So that's going to be 12 factorial divided by, in parentheses, 12 minus 3 factorial. And my denominator, 12 minus 3 is 9. So that's 9 factorial. And what we're going to do is let's expand the larger factorial, which is in the top, and to reach the bottom factorial in the bottom. 12 times 11 times 10 times, let's stop here at 9 factorial. And the reason why we're stopping here at 9 factorial is because we can simplify pretty simple, which is right here. And we're left with 12 times 11 times 10. And we know that 12 times 11 times 10 equals to 1,320. And then the last way you can find your answer for a question like this is by doing it in your TI 83, 84 calculator, or any calculator that has the functions. Because, rather not because, what I'm talking about. Let's go ahead and compute the permutation. Put in your first number, which is 12. After that, you're going to go to math. Math, go to PRB. You're going to pick number 2, which is a permutation. After you click on that, put the second number, which is 3. Hit enter, and you get your total of 1,320 ways. Okay, let's recircle that. All right, guys, that is it for this question. And let's move on to the next one. Number 20 says, provide an appropriate response. In a contest in which 9 contestants are entered, how many ways can the 5 distinct prizes be awarded? Now, when it comes to prizes, there is a rank and an order. And it says 5 distinct prizes. That means each prize is different. That means there's no repetition of prizes being awarded. So we're given 5 prizes. Prize 1, prize 2, prize 3, prize 4, prize 5. P1, P2, P3, P4, P5. Once again, distinct means that they're different. Which means that there is no repetition. Okay, let's continue. And because there's prizes, that means the order is also important. So once again, we can use the fundamental counting principles. 9 contestants can win the first prize. After somebody wins the first prize, 8 contestants for second prize. 7 contestants possibly can win the third prize. 6 contestants can possibly win the fourth prize. And you have 5 contestants that can possibly take the last prize. And let's multiply. Nine times 8 times 7 times 6 times 5. That is 15,120 ways. We can also set this up as a permutation as well. I wonder, do I have any room to write it as a permutation? Not, I'll write it up here. The permutation of 9 prizes, choosing, 9 contestants, choosing 5 for the prizes, is equal to, let's zoom in. That's going to be 9 factorial divided by, in parentheses, 9 minus 5 factorial. 9 factorial over 4 factorial. And then expand. 9 times 8 times 7 times 6 times 5. Stop here at 4 factorial. Because the 4 factorial on the top and bottom will simplify each other out. And we already know what 9 times 8 times 7 times 6 times 5 is equal to. That is equal to this number right here. And then finally, you can do it in your calculator by using the permutation function. Put your first number, which is 9, hit math, go to PRB, hit the second option, put in a 5, and there you go. All right, guys, this is it to the video. Hope it made sense. Hope you enjoyed it, and I'll catch you around. Take care.